Right, so this is then the Osmosis Required Practical. Now, it is a very, very popular one to actually get picked on, right? Mainly because you've got osmosis, so you need to know the definition of it. It's one that actually works so that people can kind of get a bit of an understanding of it. There's a bit of maths involved when you're creating a table, and there's also a graph that you draw. And from the graph, there's also an important kind of answer that you can come from the graph. But the whole point in it is to investigate the effect of a range of salt or sugar solutions on the mass of plant tissue. Now, I've put plant tissue there because what we're going to do is we're going to talk about potato, right? But it could be carrot, swede, I don't know, leek, which would be a pretty cool one to actually do, all right? You don't know, but the process is identical. It doesn't matter what the actual vegetable is or plant. Now, osmosis. Osmosis is the movement of water from a solution with a high concentration of water to a low, or to molecules to a solution with a lower concentration of water through a cell's partially permeable membrane and is passive, which means no energy. Now that's a definition, right? It's quite a long one, right? But what you've got to do is you've got to make sure that you have a definition in your head of exactly what osmosis is. Now, the experiment itself, right, it's kind of quite basic and it's kind of quite crude, all right? So if I just go through the equipment, you got your potato, right? You've got a cork borer, right, which is this kind of little tube thing here, right? And the idea of that then is to take out an identical width cylinder every single time. You've got a ruler, a white tile, that is then for just chopping on. You've got a scalpel, right? I've got a knife here, but a scalpel won't be better. So that the scalpel is then to get the actual lengths of the pieces of potato the same. You've got a measuring cylinder, right? You've got 5 boiling tubes, 1, 2, 3. Let's draw another one in and then another one in. There you go, you've got 5 boiling tubes now. Test tube rack, which is obviously this wooden thing here. A range of sugar or salt solutions, they will then get provided for you. That's supposed to be a beaker, so you've got beakers of sugar solutions or salt solutions. And a top hand balance, right? So that is then your mass balance for actually weighing it. But it needs to be pretty accurate at 0.01 grams because some of the changes are pretty small. Now, a method, right? So number 1, use a cork borer to cut 5 potato cylinders of the same diameter. So what you do is you use your cork borer, and what you'll do is you'll find that you then get 5 pieces of potato the same diameter. Now, there'll be different lengths, so what you've got to do is you've got to make sure, using your ruler and your scalpel, you're doing 30 millimetres. It doesn't matter if it's 35 millimetres or 25 millimetres, right? But for the purpose of a practical like this, if you write down 30 millimetres, it shows what you're talking about. Number 2, accurately measure the mass, right? So what you do is you put that on the mass balance. Right, and then what you've got to do it as accurately as you possibly can and record your measurements in the table. So don't forget, when you're doing this, you've got to talk about every single little aspect of it. So you record it on a table, right, because then that again shows you know exactly what you're talking about. Measure 10 centimetre cubed of water and each concentration of sugar solution. So on the next slide, I've got a kind of a diagram of it, but what you'll do is you put that one in water, that one in the next sugar solution, next sugar solution, next sugar solution, next sugar solution. Can't even say sugar, all right? Or it could be salt. Number 5, add 1 potato cylinder to each of the boiling tubes. So you've got your boiling tube with your 10 centimetre cubed of liquid in, put in your piece of potato and leave it for 24 hours. Again, the numbers are important. So 24 hours, 10 centimetre cubed of liquid, 30 minutes, right? So just get that and blot it dry. Don't squeeze it, so you're squeezing the water out, but just get rid of any surface water, which is number 6. Then measure your new mass. Record your measurements for each concentration in your table. Make sure you mention the actual fact that you're using, right, your table to actually measure things. Then there's a bit of maths that I'm then going to go through. Number 8, 9 and 10, calculate your percentage change in mass. Okay, again, remember this is your method. So you probably get 4 marks if it's a 6-mark question for the first bit, and the extra 2 marks will then say what you're going to do with it. calculate the percentage change in mass, draw a graph, and then you've got a final question here is what percentage sugar is in the potato? All right, and what I'll do is I'll show you how you work that out. Right, here's your setup. You got 1, 2, 3, 4, 5. Make sure they're labelled. These sugar solutions at the bottom here, they will vary depending on what you've actually got in the GCSE question itself. 1 will always be a control, which is then your distilled water. Distilled water is then pretty much water without any impurities in it at all. Right, it's been boiled and then collected. Right, now here is your results table. All right, and again, these numbers here, they're going to vary depending on the exam question. You've got your initial mass, you've got your final mass, you've got your change in mass, and then to work out the change in mass as a percentage, which is what you've then got to do, it's 0.45 divided by the initial mass, which is 4.97, that's a naught, times by 100. Okay, and that should come to 9.05%. All right, because that's behind my face there, that is a times 100. All right, you then got to do, and the chances are what they'll probably do is they'll probably leave that blank. All right, and then leave that blank, and you've then got to work it out. Okay, but again, it's very, very difficult to predict what they're going to do, so you've got to know how to do every single little step. Right, so now what we've got is we've got our change in mass as a percentage. Before we do the graph, we've got to look at our variables. So, good way of remembering it, don't mess in class, stay calm. So, the dependent variable is measure, right? So, what are you going to measure, right, during the practical itself? All right, so you set it up, there's your boiling tube, there's your piece of potato in there, there's the liquid. What do you measure during the practical? You will measure the change in mass. Independent variable, don't mess in class. Independent variable is what you change between practicals. So the dependent is in the actual practical itself. The independent is when you set up your next one, what have I changed? And this is then concentration of sugar or salt solution. Stay calm is your control, right? So what are you going to do? You're going to keep the size of the potato the same. You're going to keep the volume of the solutions the same. You're going to keep the temperature in the room the same. You're going to keep it the amount of time that it's in the boiling tube exactly the same, right? That's just a few examples of control. Now, on the method that I talked about before, right, what happened was it said, what is the concentration of the sugar or salt solution in that potato? Okay. Now, what you'll have is, if I just do this in green now, what you'll have is you might get asked to plot the line. All right. Now, when you're actually getting to plot the line, you do a line of best fit. All right. And my biggest tip on that one is if you look at a line, right, and it looks like a straight line, then the line of best fit is a straight line. For this one, right, it doesn't quite, if you kind of ignore the line that was on there already, if you kind of look at it, it doesn't look like a straight line. It actually looks like a curve. So if it looks like a curve, then what you do is you draw a curve. Then, when you've actually drawn the actual line of best fit, right, you have to do it as accurately as you possibly can because they are looking at you, plotting the points and drawing the line of best fit as good as you possibly can. The final question will be, what is the concentration of sucrose solution in that potato? And what you do is you look at where it crosses that axis there, because at point 0 there, it hasn't changed mass. So therefore, it hasn't changed mass. That means no water's gone in and no water's gone out. So it must be the concentration of sucrose in that actual piece of potato. Read it as accurately as you possibly can. So to me, that looks like 0.3, right? And then you're going to write down moles per decimeter cubed, all right? Accurate, right? Units. Make sure that then what you're doing is you're doing each individual part to then get to your answer. Now what you need to be able to do now is you need to be able to kind of recite all that back, right? They're going to miss out bits, they're going to add bits in, right? But the most important thing is you know the whole process, right, of the Osmosis Required Practical. Right. So osmosis required practical, you need to know the definition. Okay, you need to know a method. Oops. Right, you need to know your calculations from your table, and you need to know how the graph actually works. Right, and each one of those different things could be part of it, and it could be like a 12-mark question where what it does, it starts at the start and talks about what osmosis is, then it talks about the method. Right, you've got your calculations, so in here you've also got your variables, so you need to make sure you know your variables and what they are. You need to know how you do your percentage change in mass, and then you need to know how you draw the graph. Right, but don't forget where it crosses that horizontal line here, if that's what the line is, that is then when the concentration of the potato doesn't change, which means that is the concentration of sugar salt solution in the potato.
So now you've watched the required practicals. Now what you've got is instructions about what you have to do. If you're unsure about anything to do with the video, then you need to go back through it. In the exercise books, don't write out the questions themselves. For shorter answers, just write out the answers that you're using in the question, The longer answers, do a plan, make sure you get the right order, and then bullet point or small, precise paragraphs. Don't do long reams of writing, it's not the way to do it. The questions are then on the next slide. Pause the video, and then when you've written the questions, review and see if it all makes sense.